So in this video, we're going to look at another example, and in this case, we're going to look at an example a couple of different ways. So to start with, take a look at this table that's provided here. This is fairly common, although nowadays, normally instead of having a printed table, we would have like a spreadsheet or a computer app that would do this for us. But anyway, the table below gives the monthly payments required to pay off a $1,000 loan given the interest rate and the length of the loan. So if we were to borrow $1,000 and let's say it was 4% interest and we were going to pay the loan off in 3 years, then the payment would have to be $29.53 per month. On the other hand, if we had a loan that we were going to use for 10 years, let's say we borrowed $1,000 for 10 years, and let's say the interest rate was 6%, then our monthly payment would be $11.10 for that $1,000 loan. Now, usually someone's not going to borrow $1,000 for 10 years. So the usefulness of this table is that if it wasn't a $1,000 loan, say it was a $10,000 loan, then all we would have to do is take 10 times this payment in order to figure out our monthly payment for a $10,000 loan instead of a $1,000 loan. And we're going to see that in example 4. So in example 4, a recent graduate owes $15,000 in student loans with an annual interest rate of 8%. She wishes to pay off the loan in 10 years. A. Calculate the monthly payment for this loan using the formula for finding payments on an amortized loan. And then in B, we want to calculate the monthly payment for this loan using the table above. So to do part A, we're going to use our formula P times 1 plus R over M raised to the n power equals R times 1 plus R over M raised to the n minus 1 over R over M. We're going to use this formula in order to calculate what the monthly payment would need to be. In other words, we're going to fill in the information and solve for R like we did in the previous video. So in this particular case, our principal is $15,000. That's the amount of the loan. So P equals $15,000. The interest rate's 8%, so R equals 8% or 0.08. We know that we're compounding monthly because we're making monthly payments, so M equals 12. And we know we're going to pay off the loan in 10 years, so T equals 10 years, which means N is equal to 12 times 10, which is 120. So we're going to make 120 payments. So using this formula, I'm going to have 15,000 times 1 plus, filling in R, so that's 8% divided by 12, and that's going to be raised to the 120th power. That is going to equal R, and R is going to be times 1 plus 0.08 divided by 12, again filling in my interest rate and M, and that's raised to the 120th power, minus 1, and that's going to be divided by 0.08 divided by 12. So we need to solve for R. So if I enter this into my calculator, and this time I'm going to just enter it straight in on my calculator. So I'm going to take $15,000 times parenthesis 1 plus 0.08 divided by 12, close parenthesis, and that's going to be raised to the 120th power. So that is $33,294.60, but again, I'm not going to round, so I'm going to carry out the 352. So here on the left, we have $33,294.60352. On the right, we're going to have R times, and again, I'm going to enter this all into my calculator in one big entry. I'm going to move my calculator over here on this side. So this part in the parentheses. So I'm going to start by putting a parenthesis for the numerator, and then I'm going to need a parenthesis for the 1 plus 0.08 divided by 12. So 1 plus 0.08 divided by 12, close parenthesis, that gets raised to the 120 power, minus 1, close the parenthesis for the numerator, and that gets divided by parenthesis for the denominator, 0.08 divided by 12, close the parenthesis for the denominator. And so that is 182.9460352. So 182.9460352. Again, I don't want to round because I don't want rounding to cause error. So R times that equals this big number here. So R is going to equal the $33,294.60 plus cents divided by the 182.9460352. So if I do that, 33,294.60352 divided by 182.9460352, that is equal to 181.99. So this student's payment is going to be $181.99 per month for the next 10 years. So that is the amount of the payment, and as we were instructed in Part A, we calculated that using our formula for finding payments on an amortized loan. Now, in Part B, we're supposed to use this table to do it. And the table will actually be much easier provided that we have an entry. So we're looking at a 10-year loan, so we're going to be looking at this column, and the interest rate is 8%. So we're going to be looking at this row. So according to this table, a $1,000 loan would cost $12.13 per month for 10 years. So in this case, we have a $15,000 loan. So in order to calculate the payment, all I'm going to do is take the $12.13, which is, again, that much for a $1,000 loan if it's for 10 years at 8%. And I'm going to multiply that by 15 because we have a $15,000 loan. So if I bring my calculator back in, $12.13 times 15, that is $181.95. So according to the table, the payment would be $181.95. Now notice there is a 4-cent discrepancy. That is because this has been rounded to the nearest penny. This answer is actually more accurate, but it really isn't going to make that much of a difference, the 4 cents. That would be made up at the end of the loan at some time. So we could calculate this two ways. We can use our formula, which is complicated, or we can use a table such as this, which is less complicated because the work's already been done for us in that table. So let's take a look at another example. We'll do that in a new video.